So in this video, I'm going to discuss two more types of beans in details. And as I've already mentioned earlier in my previous video that I am writing cover point for a very simple buffer design. Both the input and output are of 7 bits. And these are some of the transition beans and repetitive beans which I have written in my earlier videos. And this is just a regression check for all the possible values for a 7-bit signal, which is A. And these are some of the stimulus which I applied through my previous videos. So I will continue with some other types of beans. So the first type of bean which I want to show is a Goto repetition bean. So let's name our bean to be B6. And to write a Goto repetition bean, you just have to mention some value. So first I want it to transition to 3. Then from that it should transition to 11. And then let me write it first, then I will explain it in details. Then this is the symbol of Goto repetition. And similar kind of, the same concept is used in assertions. So here I want it to be 2. And then it should be 17. So just a second. So what does this transition or what does this sequence imply? So this basically means that once the signal get a value of 3, then after that, at any time, it is not a requirement that it should transition to 11 or right on the next time slot. It can transition to 11 at any time. It can transition right after 3 in the next time slot, or it can transition to 11 at any time. Then since I have written 2 here, so it should transition to 11 for 2 times in at any time slot. So it should not come immediately after this 11. So again, it could come after this 11, and it could also come anytime after this 11. So after that, I have written 17. So since we are using a Goto repetition, the 17 should appear right after the last occurrence of 11. So right after this 11, 17 should appear. So I will recall it for one more time. Whenever it notices a value of 3, it will begin a process in which it will detect, it will just look for 11 at any time slot, after 3. Then after that, it should record another 11 at any time slot after the first occurrence of 11. And then right after that, in the next time slot, it should detect 17. So this is the sequence which we are getting by writing this format, which is known as Goto repetition. So let's just go ahead and just provide the respective stimulus. So as you can see it right here that I am providing a regression right here. I'm running a regression. So here I'm providing all the possible values from 1 to 127, from 0 to 127. So here only it will just transition that when I equals to 3, it will transition to 3. So it will record 3. And also at some point when I becomes 11, it will transition to 11. Since it's not a requirement that 11 should come right after 3, therefore it will detect this pattern. So this particular pattern is already being detected right here. So we just have to write the following patterns to make this particular bean to get a hit. So the first 3 and then the first 11 occurs right here inside this for loop in which I'm providing stimulus. So after that, it should have 11 at any time after the first occurrence of 11. So I will just go ahead and provide 11. And since this time it is changing, the value of A is changing, we do not require a manual sampling method. So after that, right after 11, right after the last occurrence of 11, it should transition to 17. So that's why right in the next time slot, I will just provide a value of 17 to A. So now our transition is complete and it should record a hit. So let's go ahead and compile this code and also run the simulation using my do file. So let's run the coverage report. Okay, as you can see it right here that our bean B6, which is recording, just a second, which is recording the go to repetition transition is getting a hit because we have provided all the possible transition that it requires. So the first two transition is happening inside this regression loop, and the remaining of the two, which is the 11 and right after 11, 17, I have provided those two right here. So such kind of repetition or transition pattern is known as go-to repetition. And it is also used in assertion. So the second category which I want to use is, first let's name our bean B7 this time. And I will just go ahead and copy and paste this. So this time I will be using the other category which is known as consecutive repetition. So it is very similar to go to repetition. The only difference is the first difference is of course the different symbol. You just have to use equal to before the number of repetitions you want for the particular signal. And then the difference is that 3 will transition. So when it records a transition to 3, then like same as go to repetition, it will look for the transition from 3 to 11 at any time slot. So when it records 11, then again it will go look for 11 at any time slot. It should not be right after the first occurrence of 11. And when it does record the another 11, uh, the only difference is that it does not it will not record the 17 right after it. I mean, 17 does not have to come or occur right after 11. It can occur anytime right after the last occurrence of 11. So it can also occur right after 11, and it can also occur any time slots later, any time slots after 11. So that is the only difference between the Goto repetition and between this one. So in this one, when you mention something like this, so the last signal should appear right after the final occurrence of that particular signal for which you are using the Goto repetition. So, but here it is more relaxed. You don't want it to appear, it is not a necessity to appear right after the last occurrence of 11. So our particular stimulus is already satisfying the condition, so it should get a hit. So let's just go ahead and simulate the code. So as you can see it right here that our pin B7 is getting a hit, and it is not a mandatory requirement for 17 to appear right after the last occurrence of 11. So just to prove this, just to prove the difference between this and the Goto repetition, first let's name this, and it is known as non-consecutive repetition. And just to prove my point and the difference between these two, I will just provide some more values between 11 and 17. Let's give it this time any value. Let's say 111, or then again let's give it 90. So since this time 17 is not appearing right after 11, the bean B6 will not get a hit, but still pin B7 will still get a hit. So let's check for that. So I will go ahead and compile and simulate the code. So as you can observe it right here that the bean B6 is not getting a hit this time, but bean B7 is still getting a hit. So which proves the difference between the Goto repetition and the non-consecutive repetition. So that's all for this video. So in my next video, I will be going through ignore beans and illegal beans and the order of precedence between them. So stay tuned for more. Thank you so much.